Okay, I got cut off there. Anyway, we're looking at this loop here, and this occurs in a form. And the form has this list box in it. You can see it here. It also has this button here. And the name of this list box is LST data. And there are items. We call a list box can have different items, just like a button can have text, it can have colors, and so on. List box can have different items. And if we want to add items to a list box, we use this syntax here. We say the name of the list box, we say items, and then we dot add. Add is a method, and this is what we'll add to the list box. So here is what we're adding to this list box. Okay, so we said this is the whole thing here is a for loop, and we see that I is going to be an integer, and it starts at 0, goes to 10, and the step is 1. So it starts at 0, then it becomes 1, then 2, then 3, then 4, then up to 10, because the step is 1. If the step was 2, it would go 0, 2, 4, 6, 8, 10. But here it just goes by step of 1. So I is going to go from 0 to 10. First I is going to be equal to 0. In the first, we say the first iteration of the loop, or the first cycle of the loop. So we have what's going to happen, and this is the body of the loop is here, these two lines, this line and this line. So what's the first line? In the first line we're creating declaring a variable. The name of the variable is myString, and it's a string. And this is what it's going to be set equal to. And here we see we have a quotation and a quotation, so this is a string, and then this is concatenation, and this is concatenation, so we're concatenating I, and then we're concatenating this string. Okay, so what is I? I is the index of the loop. We call it the index of the loop. So I starts out at 0, so the first time we go through this, I is 0. So then my string is going to be I'm item 0 in the list. And then we're going to add that to our list box. So we're going to print this in the list box. I'm item 0 in the list. But we're not finished, because this is inside a loop. So the next time, so what happens next is I then becomes 1. I then becomes 1, because we said starting at 0 and stepping by 1. So I is now 1, and then we're going to again define a string called myString, and it's going to be I'm item 1 in the list, and that's going to be added to the list box. So we're going to print next item in this list box. So each one of these is called an item in the list box. The next item in the list box is I'm item 1 in the list. And then it's going to be, I is now 1, now it's going to go back, and I is going to be incremented to 2. So it's going to say I'm item, so obviously it's going to say I'm item 2 in the list. And this is going to keep going until we get to 10. It's going to also write for 10, I'm item 10 in the list, and then it's going to stop because it doesn't go any further than 10. So what we're going to generate in this list box is all of these. Okay? And that's how, that's an example of this if-then loop. Okay? All right, we'll come back, and, well, I guess we better go back to the beginning. So let's start here. So he says, so far our programs have been acyclic. Acyclic means not cyclic. In other words, we didn't go in any loops. We didn't go in any circles. We have discussed both linear and branched programs. We did talk about branches, and the way we got a branch was we used if-then. So if it was in an if-then statement, if something was true, then we would do one thing. We'd go along one branch, and if it was false, we'd do something else. We'd go in a different direction or a different branch. So that's called branched program. So if-then statements allow you to do branches, but they don't allow you to do these cycles or these loops. So we've discussed both linear and branched programs. So linear would mean you don't have any branches and you don't have any loops either. Um, in which process paths are executed once or not at all, with no repeated processes, no cycles. Okay. However, real algorithms often use loops. So a lot of times we want to use loops, i.e. Programmed or controlled repetition of a basic process. And we just saw 2 examples of this already. We're doing a repetition of something. And for example, make a telephone bill for all of your customers, not just one. So you could have like some code in the loop that generates a telephone bill. But you want the loop to go through the an entire list of all of your customers and do the same thing for each of them. So that would be a little more complicated than than the 2 examples we've seen so far. But that would also be, could also be done using a loop. You repeat the same thing over and over again. It repeats the same basic process for each customer. The act of repetitively cycling a process is called iteration. So I was using that word, iteration. And next, blocks of code for looping are called loop structures. So we've seen 2 loop structures. As noted in the outline, VB.NET provides several different flavors of loops, several different kinds of loops. So we've seen so far the for next loop. This one here, we've seen the first one, and they're also called for loops. And we're also going to see something called a do-while loop, also just called a do loop. Each of these provides a means to control the program flow. Well, we saw that we do something 10 times, or we could do it 20 times, or whatever, so we're controlling the flow of the program via controlled cycling, also called iteration. So we go through it once, that's called one iteration. Then we do it again, that's the second iteration. Then we do it another time, that's the third iteration, or the third cycle. Let's take a look at the simplest, and that's the for loop. Well, they're all pretty simple, but maybe the for loop is the simplest one. All modern languages support at least one type of for loop. So it's not just VB.NET, but if you check out any other programming language like Java or C# or any other one, they're all going to do this kind of thing, and they're all going to be almost the same syntax also, not exactly the same, but pretty close to the same. This loop allows the repeated execution of a set of statements. With loop termination, so when do we stop the loop? We stop the loop based on this, the end, right? And also the step, right? With loop termination, based on the test of an auto-incremented loop index. So he's saying, again, we're testing whether, remember, whether it was equal to, 10 or not, whether we've gone above 10 or not. But I'm not sure we have to say that so much when we're talking about a for loop. But if you want, I guess you could say it that way. You could say we're testing, is it greater than 10 or not? In the do loop, that's exactly what we do. But in the for loop, I'd just say we're just doing it 10 times, or 1 through 10 times, step 1. Okay? But anyway, so he's saying that we're kind of testing each time, have we exceeded the end value? Okay? Based on the test of an auto-incremented loop index. So this is called the index, so I. We used I so far. Okay, so this is the general format of a for loop. For the index, we used I, as integer, equals, we did 1, 2, 10, step, so this was 1, this was 10, and this was 1. I think we also did 0, 10, and 1. And then this keyword and this keyword, 2, and step. And then we have some statements in here that we want executed each time we go through the loop. and then we have to end it with next, so it knows which statements to do in the loop, and then everything after next it won't do inside the loop. Okay, index is an integer, so this should be an integer, and it's defined as an integer. It's called the loop variable, which index or counts the number of loop iterations. Not exactly, because if we did step equal to 2, the number of iterations wouldn't be, I don't know, wouldn't be 10. But anyway, is initialized to the value start. So it starts with start. So we had 1 there, we had 0 there. And defines a loop test condition. So he's again saying it that way, which is evaluated at each iteration. So he's saying we're checking, is I greater than 10 or not each time. If I becomes greater than 10, then we stop. If the index is less than n, then these statements are executed. Otherwise, the loop terminates or ends. Okay? Step, which is optional. So you don't have to have this here, but if you leave this part out, it's going to assume step is 1. Step's the increment value of the loop. The default is 1. So if you don't put in anything here, if you just leave out step, or whatever, you leave out these two parts, then it'll assume it's 1. After each execution of statements, after each execution of what's in here, index is incremented by step. In other words, index equals plus equals step. Remember that? Note, if step is negative, you can loop backwards. So you could put negative values in here. So if you suppose you did 10 and 1, so start was 10 and end was 1, and you said negative 1 was the step, it would go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? Next, this one here, tells the running program to loop back to for index and test the condition of the loop based on index to see if another cycle is to be executed. Okay, here's the flowchart for the loop. We looked at this, but let's just look at it again. Example, calculate the sum of all integer values from 1 to 10. We use a for next loop with loop variable I to both index the integers while also controlling the looping. So it's going to be used in here, which it doesn't always have to be, and it's also, it's used in here, which it doesn't always have to be, and it's also used to control the loop. Okay? And variable total to store the sum. So total will store the sum. The for loop's flow of control is clearly shown using a flow chart. So we can see it here, the flow chart. Starting cycle 1, I equals 1, total is 0. After cycle 10, the total is 55. The value I equals 11 fails the test, which stops the loop. Okay, and we saw this, but let's read what it says here. Add a list box from the Visual Studio toolbox. So you should be able to find this. It allows us, so you're going to have the form, and then you're going to add the list box. It allows us to manage and display a list of items. Okay, and set the name equal to LST data. Note, LST is short for list, not first. Doesn't mean first. And set integral height equal to false, allows us to view partial list entries. And you could check what happens if you set that to true. And anchor equals top, bottom, left, right. Allows the list to stretch when resizing. So if you resize this, it allows us to stretch this thing as well. Okay, so set those. and the button is btn go, text is go, and anchor equals top comma right. So set these properties, and then try this out. Here, during, let's see, we use a simple for next loop. Our loop variable is I. Our step is 1. So it can also be omitted. You don't have to put this part in there. Here, during each loop cycle, each iteration, we add a string message to our list, these. The items are contained in listItems.data, which is what's called a collection. So this is a collection, but we'll learn about collections later. But anyway, it's stored in here, which is part of our list box. The function listbox.add item, so this thing here, this dot add, I think, wait. I think he skipped something here. I think he needs item in here. Adds each item to the end of the list. I think. Maybe I'm wrong. I'm not sure. We'll check that later. List box items are displayed top to bottom at runtime. So we get this top to bottom at runtime. So, okay. If we wish, we can add items to our list manually using the properties window. Items, property, and so on. Okay. Okay, let's stop here and then discuss another way to do this called a do loop. So it's the same thing, same idea, but a little different way to do it.